Hello friends and welcome to my channel. In today's interesting lecture, I'm going to show you how to derive the quadratic formula. Back then in high school, we were only taught how to use it, but we were not taught how to derive it. But in today's interesting lesson, I'm going to show you where it comes from and how to derive it. Without further ado, let's get down to business. The quadratic formula can be derived from this expression ax squared plus bx plus c equals 0. This is the general form of every quadratic equation. For example, let's say you have 2x squared plus 3x minus 4 equals 0. This expression here, or this equation, can be compared to this. If you compare this one to this, you will discover that your A, okay, your A for this is equal to 2. So this right here is your A. And your B is the number in front of x. Your A is the number in front of x squared, while your B is the number in front of x. In this case, it's a 3. And lastly, this is a C, which is a constant, okay? Any number that takes the place of C that has no x term, okay, is simply the constant. And our C is equal to -4, okay? Now, whenever you're given any quadratic equation and asked to solve it, whether using completing the square, the formula method, or by factoring, you need to identify your A, B, and C values. So this is how it looks like. But to derive the formula, we shall work with this one here. This is the general form, and this is what will help us to get what we want. Now, how do we do this? The first thing that you're going to do whenever you are asked to derive the quadratic formula is to transpose your C to the other side. Transpose it to the right. Okay? Now, we are doing this by completing the square. So, to derive the formula, you need to be conversant with how to complete the square. First of all, transpose your C across. When you transpose your C across, what do you get? We now have ax squared plus bx is equal to -c. Remember, this is a plus c. When you transpose it across the equality sign, it now becomes a -c. Next up, divide everything by a. Divide the left part of the equation and the right part of the equation by a. Why do we do this? For example, if you have 2x squared minus 3x plus 4 equals 0, for example, and you are asked to solve this equation by completing the square. The first thing that you have to do here is to transpose your 4 across, and now becomes a -4. Next up, you're to divide everything by 2, because you cannot leave this 2 here as it is when completing the square. Okay? The coefficient of x squared must be 1 whenever you're completing the square. So this is not going to be, if you divide this by 2, here you have is equal to -4 over 2. Okay? Now, the 2 will cancel out with the 2 at the denominator, and what do you have? X squared minus 3 over 2x is equal to -2. -4 divided by 2 will give you a -2. Okay, so whenever you are asked to complete the square, you are going to make sure that the number in front of your x squared is always 1. That's 0. So if it's greater than 1, or if your a is greater than 1, you must divide the entire equation by your a. Okay, your a is 2, so you must divide everything by 2 in order to make your a equal to 1. That's 0. Now let's continue with the solution. I'm going to divide everything by a. If you divide everything by a, what do we have? The a at the top cancels out with the a at the denominator, and we're left with x squared plus bx over a, or we can say b over a multiplied by x is equal to negative c over a. Next up, what do? You are going to look at the coefficient of x. Okay, the coefficient of x here is b over a. Now, get half of the coefficient of x. In this case, if you have 2x, for example, the coefficient of x in this case is 2. Now, if you look at the number or the term attached to the x, this is our coefficient of x in this case, which is b over a. So the rule says get half of the coefficient of x, square it, and add to both sides of the equation. Now, what does that mean? We are simply going to get half of b over a, square that half, and add to the left, and also add to the right. Now, let's do that. For example, let's say you have b over a. What is half of b over a? It's as good as dividing b over a by 2. Okay? Now, this thing here can be rewritten as b over a divided by 2. Okay? This is 2 over 1. It's also the same thing. Now, we take the reciprocal by changing the division sign to multiplication. And what shall we have? We now have b over a times 1 over 2. Right? Remember, we're dividing, we're getting half of b over a. And when we get the half, we square and add to both sides of the equation. Now, let's multiply. B times 1 gives you a b over a times 2 gives you a 2a. Therefore, b over 2a is half of ba, or b over a. b over 2a is half of b over a. Now, let's assume that you're solving a quadratic equation and the coefficient of x in this case is 4. Okay? Let's say you have 4x right here. You are expected to get half of 4, square that half, and add to both sides. What you do is to say 4 over 2, because 4 over 2 will give you half of 4. This is equal to 2. Okay? Now, when you get the 2, you can square the 2 and add to the left part and the right part of the equation. We've seen that the half of b over a is b over 2a. Therefore, we're going to add b over 2a squared to both sides of the equation. Let me do that here. Here we have x squared plus b over a multiplied by x. Remember to add b over 2a, which is half of b over a, to both sides of the equation. Therefore, we have plus b over 2a. You square it and add to the left first. This is equal to negative c over a, or we can decide to first of all write the square term first before we pick the c over a. It's also the same thing. Let me write this one first. We now have b over 2a, okay, all squared, minus, remember this one here, this one has to be there, minus c over a. All right. So what next do we do at this very point? Let's distribute the 2 across everything inside the bracket. We shall do for the left and also for the right. Here we have an x squared plus b over a multiplied by x plus b raised to power 2 will give us a b squared over 2 raised to power 2 is a 4. A raised to power 2 is a squared. This is equal to b raised to power 2 will give you a b squared over 2 raised to power 2 is going to give you a 4. A raised to power 2 will give you a squared minus c over a. Okay. Now, what are we to do at this very point? Let's work on the right first. This right has 2 fractions. The b squared over 4a squared minus c over a. So these are 2 different fractions. Our task right now is to combine them into a single fraction. This fraction here is just like when you have 1 over 3 minus 6 over 2. Okay, they are not the same. They don't have the same denominator, so you cannot add them. But we can use the LCM of 3 and 2 to write this or to write this into a single fraction. How do we do that? We simply say the LCM of 3 and 2 is a 6. Then we say 6 divided by 3 will give us a 2. 2 times 1 is a 2 minus. Next up, 6 divided by 2 is a 3. 3 times 6 is 18. This now becomes 2 minus 18. We've gotten a common denominator for the two of them. And that is just how it works. So you can now subtract because the denominators are the same. We shall also employ the same method here. Now let me rewrite this again. We have x squared plus b over a multiplied by x plus b squared minus 4a squared is equal to, let's now get the LCM of 4a squared and 4a. The LCM of 4a squared and the LCM of 4a squared and a is 4a squared. Okay, the LCM of these two terms is 4a squared. Now let's do the division and multiply. 4a squared divided by 4a squared is a 1. 1 times b squared is b squared. Next up, 4a squared divided by a will give us a 4a. Okay, you have 2 of the a. If you remove 1 from them, or from them, you're going to be left with 1. So 4a squared divided by a will give you a 4a. Now 4a times negative c will give you minus 4ac. Okay, I believe you understood what I did here. What I did was I got the LCM, just as I did here, the LCM of 3 and 2. In the same way, the LCM of 4a squared and a is 4a squared, right? So you now say 4a squared divided by 4a squared will give you a 1. 1 times b squared will give you b squared. 4a squared divided by a will give you 4a, because you have 2 of this and you remove 1 from it. You're now left with the 1. It now becomes 4a. 4a times negative c will give you minus 4ac. All right, let's continue. I'm going to write it up here. What do we do next? Okay, so before I write it up here, we've combined this from this to this. We've converted this to this. They now have a common denominator. Now let's work on the left part. We are now going to factor this. Okay, we shall factor this right now. And to factor this, I'm going to pick the first term. Always pick the first term here. Okay, pick the x. Ignore this one here. Pick this one. Okay, so you ignore the x and you go to this one with a sign. So everything here, you pick it. Okay, now let me show you how to do it. We're trying to factor this so that it's going to be smaller. And if you factor it and also decide to expand it, you'll still get everything here back. So when you pick the x, ignore the 2. We shall square it afterwards. If you pick the x, here we have an x. We pick the sign here, plus. We pick the b. You write a b over. So this one here, we pick a 2 from it. We have a 2. And this one, we have an a. You can square everything. All right. Now, let me explain this part again. Here you have x plus b over 2a squared, right? If you expand this expression, you get everything here back. If you decide to expand this, you get everything here back. So you can try that at your free time, okay? Now, what you do is you pick the b. Here you have a 4, okay? So the square of 2 will give you a 4, all right? So you simply copy down this one here, okay, the x, ignore the 2 or the square. You ignore the second term, okay? For this one, also ignore the square. You just pick the b. For the down part, you also ignore the square. You just pick the a. Okay. Now, this one will now be reduced to 2 in such that if you have something like this, you can multiply them out and still get this thing back. Now, let me show you how it works. In case you're being confused, let me show you how it works. Let's multiply everything here out to see if you can get this one back. So remember, this is a square. This square means that it's multiplying itself, right? So we say x plus b over 2a. All right. Now let's multiply. I'm going to work it out at the right here. I'm trying to show you that if I have x plus b over 2a squared, okay, if I multiply it out, I'm going to get everything here back. Let's do and see how it works. Remember that x plus b over 2a squared can be written in this form because they are multiplying and the terms at the center are adding, so there is no need of distributing the powers. Now let's multiply. X times x will give you an x squared. Okay, x times b over 2a will give you plus b over 2ax. We're done with the first one. Now let's go to the b over 2a. B over 2a times x would give you plus b over 2a x. And lastly, b over 2a times b over 2a would give you plus b squared over 4a squared. So the 2 times 2 is a 4. The a times a is an a squared. Okay, now let's simplify this very expression. I never wanted to do this in the course of this video, but for the sake of proper comprehension, that was why I chose to do it. Now, x squared, okay, we have an x squared here. B over 2a x plus b over 2ax, they are like terms, like you have 2x plus 3x, okay? The x and the x, they are like terms, so 2x plus 3x will give you a 5. In the same way, b over 2ax plus b over 2ax will now give you plus 2b, okay, over 2a. All right, so b plus b will now give you, these are common denominators, so you just pick one. So b plus b will give you a 2b, 2a, and just pick one of them and it's going to give you a 2a, plus b squared over 4a squared. Okay, now if you look at this, the 2 and the 2 can cancel. What do you have left? X squared plus b over a, there's an x here, b over ax, okay, plus b squared over 4a squared. And this is also the same thing that we have here. We have an x squared here, x squared, b over 2a, b over 2ax, as we have here, b over 2ax, plus b squared over 4a squared, plus b squared over 4a squared. So when you get to this point, all you have to do is to take the first term, okay, ignore the square, and then you pick everything here, all right? And it's going to be written in this very form. So I just expanded it to show you that even if I factor it out, okay, and square it, I'm still going to, if I decide to expand it, I'm still going to get everything here back. So that's just how it works. Remember that this one here is squared. We square it back. I was only trying to show you the relationship in case you decide to prove that you're actually correct. This is equal to, we bring this one, here we have a b squared minus 4ac all over to 4a squared rather. 4a squared. All right. What's the next thing to do at this point? It is very easy to get confused when you get to this point, but do not get confused because it's very easy to simplify by applying what we call the square root property. For example, let's say you have v squared is equal to 4, right? To remove the square attached to the v, you simply square both sides. The square will cancel out the square root, and this one, okay, the square root of 4 is not going to v is not going to be equal to plus or minus 2. Whenever you take the square root of a number, it gives you two values, one for the positive and the other for the negative. And that's also what we're going to do here. The left part is squared. Therefore, in order to remove this square on the left, we simply square both sides. We square both sides. All right. Now, when you square both sides, what happens? The square on the left cancels out with the square root. Okay, it cancels out with the square root. Let's now copy this one down. Here we have x plus b over 2a. We have x plus b over 2a is equal to, I'm going to rewrite this one, this expression here, okay, in the form of, we have b squared minus 4ac all over. Remember that this 4a squared is also in the square root, but it can be written as, this one will go to the numerator, while the 4a squared would have its own square. This is mathematically correct. We only separate them, and I also assigned square roots to them. Here we have 4a squared. Okay, whenever you take the square root of a number, you're going to get plus and minus. Okay, just like I said initially. Now, we shall now have x plus b over 2a is equal to plus and minus. This numerator, you cannot take the square root of the numerator because they are the same. They are subtracting. They are just like the same. So you can't just say we're taking the square root of b squared. No. So you leave everything as they are. This now becomes b squared minus 4ac all over. The square root of 4 is 2. The square root of a squared is a. Okay? So when you have a squared and you square a squared, 1 is going to go away and you're only left with a. Now let's isolate x to solve for the value of x. We need to find what x is. We're looking for the value of x. How do we find the value of x? Let me write it up here. X is equal to what? If we want to find the value of x, we simply isolate b over 2a. This b over 2a would now go across, okay? It's not going to be transposed across because we're looking for x, just like, for example, in mathematics, let's say you want to find, let's say you have 4x plus 4 is equal to 0, for example, right? To solve for x, we simply transpose the 4 across. It now becomes 4x is equal to negative 4. We divide both sides by 4 to find the value of x. In the same way, we're going to transpose the b over 2a across, and this now becomes x is equal to b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Remember that this 2a is still here, despite transposing the b over 2a across. If you transpose the b over 2a across, it's not going to be a negative. I omitted it initially. It's going to go from a positive to a negative when you transpose it across. Now, what is it trying to tell us? What are we going to do at this point? Here we have a negative b, okay, over 2a. And here we have everything here also over 2a. We now have a common denominator. If you have 1 plus 3 or 1 over 4 plus 3 over 4, the denominators are the same. So there is no need of trying to get a common denominator. We simply add them together. This is now all going to be 1 plus 3 over 4. And 1 plus 3 is 4 over 4, something like this. So we are also going to employ the same method here. They have a common denominator. This is a 2a, this is a 2a. We now pick 1. Therefore, x will now be equal to negative b. We bring down a plus and a minus. Plus and minus the square root of b squared minus 4ac all over 2a. This is a formula we're looking for, which is called the quadratic formula. Hi friends, I believe you understood the lesson. If you have any questions, concerns, or comments, please drop it in the comment section and I'll be right there waiting for you. If you've not subscribed to this very channel, please do well to subscribe, like, and share so that you'll not miss other interesting videos like this. Thank you and see you in the next video. Bye. Na papata.